started. Welcome everyone to the first session of the Python fundamental course. WeCloudData recently launched a WeCloudOpen course, which is Python Introduction. It's a free course and anyone can access. We're just doing a live version of that. And of course, it's going to be a lot shorter. But we do hope to keep everyone engaged and help introduce everyone to Python programming, as well as SQL. So today is the part one of the the 3 sessions. Next Friday we'll do the second workshop, and the week after we'll do the third one. The material we're going to cover today is going to be very basic, but it's targeted towards folks who are just getting started with Python programming. So hopefully this is helpful. I prepared some slides. So I'm going to give you a very high level introduction. It shouldn't take that long. And then we'll go through some live exercises as I introduce the basics of Python, such as basic data types, how to do assignment, how to create variables. And then next week we'll move on to more sophisticated topics. In the third session, I believe we'll be introducing functions and modules and a little bit object-oriented programming as well. But let's start from the very basics, and I'll also mention some of the the coding environment IDEs as well. Okay, don't worry about the Colab or Jupyter Notebook. I'll give everyone a quick introduction, and all the details you need is actually in the course itself. So if you would like to access the open course, you can go to learn.weclouddata.com, and you can just sign up for an account yourself. Once you log in, you will be seeing the dashboard, and then you can just click on WeCloudOpen on the left hand, on this panel on the left hand side, and we have a couple of open workshops and courses. The self-paced courses, you can click on this filter. And right now there are 2 courses, right? SQL and Python. And later this year, we'll release some other open courses such as Linux, HTML, data science, as well as machine learning. So we're also quite excited. We'll have some introduction to cloud computing as well. Well, let me click into the introduction to Python. If this is the first time you're accessing this course, there should be another page that asks you to do self-enrollment. And you just need to click on the button to get enrolled in this course. The navigation bar is on the right-hand side. Yeah, so you can filter by recordings, by lectures. There's some welcome messages, and then we jump right into the introduction. For example, this is the slide we're going to go through tonight. I think we're going to go through 2 slide deck. The recording is pre-recorded by our instructor, so you can watch the recording. I'm just going through the live version today, and I'm going to do some live demo as well. Okay, so that's the WeCloudOpen, and I hope this is useful. There are actually lots of exercises at the end. So the chapter exercises, I think we have quite a lot of exercises. All of these exercises have solutions, and also the recording of solutions as well. Okay. And last night we had a session on data science learning path. I'm not sure how many of you were in the previous session, but we sort of worked together to come up with a learning path for data science. So we talked about SQL, Python, statistics, machine learning, some of the soft skills and data engineering skills, and I think we talked about Python. So there are 2 things you need to learn about Python. First of all, the Python programming basics, right? The fundamental programming or coding concepts. For example, you need to get familiar with data types, loops, functions, object-oriented programming. But these are the Python programming basics. You can use the skills you learn here to move on and become a Python developer, right? And of course, you need to learn things like Flask, Fast API, and maybe Django as well. But those are for full stack developers or backend engineers. But you can also use the data science, packages such as Pandas, NumPy, scikit-learn, and PySpark if you would like to do data analysis or data science. And data wrangling is one of the most important skills a data scientist need to have. And yeah, so we will be introducing Pandas later as well, but not today. Today, we're only introducing the basics. All right. I'm going to kick off my presentation. We have 2 slide deck to go through. I don't think we'll be able to finish the second one, but I'll try to cover as much as possible in the next hour. Okay. Okay. Module 0. Well, the reason why we call that module 0 is because Python is 0 index based. We'll talk about that shortly. Okay. So I'm going to talk about what is Python first. It's an interpreted, high-level, and general-purpose programming language. And this is a definition by Wikipedia. It's too abstract, I guess, if you're very new to programming. But it's being used by so many different companies. A lot of great products were actually originally built using Python. Okay, I know there are better, and maybe faster web frameworks out there. JavaScript, Java, right? But Python is actually powering a lot of the interesting day-to-day applications we use. For example, Instagram was originally written, part of it is written in Python. Spotify, Dropbox, and of course later on they move on to some other languages, but they always use Python in their ecosystem. Right? Companies like Uber, Pinterest. But they use that for different purposes, of course. A lot of organizations will be using Python for data analytics, data science, deep learning, AI. But actually, there are companies that just build their entire product and web applications using Python. Okay. Why should we learn Python as a data scientist? First of all, the job market demand. Python is always among the most popular tools a data scientist need to master. You don't really need to, use Python to build web applications as a data scientist, but you need to be very good with Python programming so that you can sort of tackle different types of machine learning challenges. And before we move on to machine learning, we always need to know how to use Python to collect data. For example, if you want to do web scraping or collecting data from the web API, that means you need to learn how to work with different Python packages, right? You need to understand the web as well, understand how to parse HTML using beautiful soup, right? You need to understand how to visualize data using Python. Yeah, so you need to be pretty good at Python programming. And it has a very large community. And I think Python is not the fastest language. It's actually relatively slower, right? It's also probably not the most sophisticated programming languages. However, the reason why it's still being very dominant and very popular, especially dominant in the data science and AI space, is mainly because of the community. And there's so many tools that's being created by the communities. And a lot of times people are actually going to choose a tool for convenience and also the support they're going to get from the community over some marginal gain on performance. Right. For some of the real life applications, performance is really important, and even a difference of the response time of 10 milliseconds matters, and that's money, right? For example, in online advertising. But in many of the applications, such as data science, it's not always real-time based, right? So it is okay that your program takes 5 more minutes to complete, or when you deal with really large data set, it may take you more 30 minutes longer. So maybe you're spending a little bit more time on the computing resource because it's going to take longer to compute. However, most of the data scientists, they're already familiar with with Python, so it's actually easier to find talents who know Python, right? And one of the very powerful programming language in the big data space is Java and Scala, and but still, PySpark, even though Spark, which is one of the big data tool, it was written in Scala. However, PySpark right now is even more popular than its original language. It's very, very interesting because people in the community, especially people dealing with data, most of them are coming from a Python background, right? Um, so that's why I think it's definitely worth it, your effort to focus on Python programming at the beginning of your data science journey. And on this chart, right, the second coding tool is R. But usually R is mentioned frequently, with Python, and it's such a beautiful language, and a lot of the visualization stuff, it's actually better than Python. It's very popular, right, in academics, but I think in the industry, Python is still more popular. So I would highly recommend just focus on one programming language at the beginning of the journey. And once you get a data science and data analytics job, you can always invest more time in learning R. But there are also folks who start their data science and analytics journey from R, and there's nothing wrong with that. Like if you started with R, maybe just focus on it and get really good at R. There are a lot of companies hiring R talents as well. But if you're still making a decision, look no further, just focus on Python because there are definitely more Python jobs out there. Okay. Another reason why we should consider Python is because it integrates better with the entire ecosystem, such as big data, cloud computing. So there are always APIs supporting Python, and R is usually not the first one to be considered. Okay. So what can we use Python for? Python can be used, well, first of all, it's just a programming language, and you can use it to build anything you want, basically. But it has a lot of industry use cases, right? For example, right now in finance, people are using Python for, automating spreadsheet, right? Doing time series forecasting, doing trading as well. Python can be used for DevOps in cloud computing, right? So for example, cloud engineers need to be familiar with Python as well. They use that for automation, for writing, let's say, AWS Lambda functions, which is serverless. And all of these cloud platforms, they provide API support for Python, which means you can use Python to automate a lot of the infrastructure side of things. Python can be used for big data, right? Projects such as Apache Spark, Dask, and even Raid.io, they all support Python really, really well. So if you would like to work with big data, then you don't have to pick up another language. You can just use Python. And of course, Python is most well known for doing AI and data science, right? So machine learning, data analytics, deep learning, and yeah, and Python can be used for data engineering as well. So many different use cases. And you can be never wrong by investing time to learn Python. Okay, I'll introduce some of the use cases. Here, on the right-hand side, we are looking at a data frame. Imagine this is actually just a spreadsheet, right? We can import, import, any kind of CSV file into Python Pandas data frame. It's just a data structure that allows us to manipulate, spreadsheet data or tabular data. Right? A tabular data typically has, rows and columns, right? And it has column names, and these are the values, right? So this type of data can actually be represented in Python using a data structure called Pandas data frame. And behind the scene, it's actually just Python NumPy arrays, okay? And if you want to become a data scientist or data analyst, you absolutely need to be very good with data manipulation, and Pandas is one of those most popular packages you need to learn. Python can be used for data visualization. There are actually many popular visualization libraries, such as Matplotlib, and it comes with the Anaconda installation. Very popular, but it doesn't generate the prettiest plots. But they're also like Seaborn, Plotly. So there are many libraries that allow you to do fascinating visualization. Plotly also has a Dash tool that allows you to build dashboard, and Streamlit is also a framework for data scientists to build beautiful data applications. Which means you don't need to be a web developer to build some sort of interactive data application. It's pretty cool. Okay. Python can be used for AI, deep learning, but for example, if we would like to do handwritten digit analysis, right? On the right-hand side, this is actually an image represented, in a NumPy array. So if we would like to recognize this handwritten digit, is it a 3 or is it a 5, right? We can actually train machine learning models to do the classification. But first of all, we need to let our computers understand this image, right? And so, but how do we read this or import this image into our computer, into the Python program, so it understands how to, interpret the data, right? And so that's why we need some sort of data structure that can hold this kind of images and in a numeric representation, and that is NumPy array. Okay, on the left-hand side, that is the data Python data structure, which is a NumPy array, and this is a two-dimensional NumPy array. So you have the x-axis and you have the y-axis, right? This looks like a 5 to me, but I think it could be 3 as well, right? So when we turn that into a NumPy array, it becomes, a 28 by 28 two-dimensional array. So it's, so on the x-axis, we call this like, if it's an image, we call that pixel, right? So it's basically 28 by 28 pixel. And then we can basically represent each pixel with a numeric number. Okay, and the numeric number is usually between 0 and 255. If the value is 255, that's the maximum value, right, for the black and white kind of pixel representation. And that is, 255 is black, 0 will be the white background. Okay, so that means, the first value in this NumPy array is 0. That's why it is a white background here, right? So somewhere here, you start to see 3, 18, right? And you can see it here. That's probably, the number, like the value 3 and 18. So those are, gray color, but almost close to white color. But that's how we can numerically represent this image, okay? Handwritten image. And then we can feed that into the machine learning algorithm, and it will, be able to do image classification. So that means understanding how to represent data is very important, right? It all starts from reading and importing the data, and we can use pandas and NumPy array to do that easily. So that's another use case of Python. Okay, Python can be used for machine learning, right? For example, k-means clustering is one of those unsupervised machine learning algorithm, but we can use, for example, PySpark. PySpark is a big data library. It can be used to do machine learning as well, but we can use Dask and Ray to do machine learning. It's not a lot of lines of code if you want to train some machine learning models. Let's take a look at Python's scientific ecosystem. Python, there are, a gazillion number of libraries you can use to do things in Python. But we're going to focus on data science, right? So let's take a look at this ecosystem. First of all, there's the core Python, right? Or the Python core, which is the Python programming language. And it's very flexible, and you can use it basically to build anything you want, right? On top of it, Jupyter Notebook, IPython, these are the IDEs. It allows us to, do programming, right? To code in the, in Python. There's the CPython or Cython and NumPy as well. NumPy is a numeric library for Python. You can use it to manipulate, vectors and matrices. So most of the statistics, as well as machine learning, is done using based on NumPy, because we always need to represent the data in some sort of array format. Okay, and on top of that, there are other higher level libraries such as SciPy. SciPy is used for statistics. It's the scientific library. Pandas is for data manipulation. It's one of those most popular. So it's based on the core Python, but it also leverages NumPy. Okay, so the data or the values behind any pandas data frame is actually a NumPy array. Okay, and the reason why we built pandas on top of NumPy is because NumPy is faster. It's not completely based on Python. It's based on another programming language called C as well. Okay, there's some other libraries such as Dask. It's a distributed system that allows you to sort of, you can think of it as a faster version of pandas, a more scalable version, but it's not as popular as pandas. And we can do visualizations using Matplotlib. It leverages NumPy as well. And on top of that, we can do things like, machine learning, right? Statistics. So we can use stats models. This is more favored by statisticians. We can, and scikit-learn is probably one of the most popular machine learning libraries. And I think most of the beginners will pick up machine learning using scikit-learn. And there's so many tutorials out there, right? PyTorch, TensorFlow, these are the deep learning libraries that can be used for computer vision and natural language processing as well. Okay, there are also some other libraries you need to learn along the way. You don't have to learn all of these, by the way. You can always just pick up whatever that's needed for the projects you work on. As a data scientist, and you always need to have an open mind. You need to be willing to, or you need to have that learning aptitude, right? To always keep learning new things. But at its core, like it's all just part of the Python ecosystem. So it's more unified API. As you're good at Python, it's not that hard for you to pick up other Python libraries. Okay. All right. How do we get started with Python? And I think we created this learning curriculum yesterday already. And I'll share the recording later on our Discord channel. So I won't spend more time on this. Okay, now let's move on to module 1, the basic syntax and semantics. This is very, very basic. Let me see if I can, I think now is the time for us to maybe get the environment set up. So for today's lab, I think I'm mainly going to do the demo using Google Colab. One second. So you can go to colab.research.google.com. I'll send you the link. You need to have a Gmail account. And then you can go to colab.research.google.com. Okay, here's the link. This is Google's version of Jupyter Notebook. It's actually very similar, okay? And it's it doesn't, so basically it's using the Google Cloud as the back end. So it's free. It has a paid version as well. But if, let's say, if you don't have very powerful computer, and then you can just use, Colab, and everything you do will be saved in the cloud directly. If you would like to run Python in the local environment, I think we have two options. We can install something called Jupyter Notebook. Let me. So you do need to have Anaconda installed. So we have instructions in the WeCloudOpen course. So I'm not going to spend time today to teach you how to do installation, but let's assume that we have Jupyter Notebook installed, and then you can just type, Jupyter Notebook in the prompt in your command line. But you can go to Anaconda and and open Jupyter Notebook as well. Let me see if I have Anaconda installed. I should have. So this is the Anaconda Navigator. My version might be pretty old, but it'll open up. Okay. So you can just go to anaconda.com and download Anaconda. It supports both Windows and Mac. And once we have Anaconda installed, and you open the navigator, and here apparently he's asking me to upgrade, but you'll see a bunch of tools, and you can launch them, and Jupyter Notebook is one of them. So you can just click on launch, But usually I prefer just to launch that directly using command line. So I will go to my command prompt and then type Jupyter Notebook to open that. You can use another tool called Spider. You can even do RStudio, use that to program R. But Jupyter Notebook so far is the most popular one, either Jupyter Notebook or Jupyter Lab. If you are data engineer, ML engineer, or a software developer, you might prefer using VS Code. So you can open any Jupyter Notebook in VS Code. You just need the plugin, and it supports Jupyter Notebook as well. PyCharm is another very popular Python IDE. It's used by professional Python developers, very popular. So I think either VS Code or the PyCharm both support Jupyter Notebook. It's not the best experience. So I think Jupyter Notebook itself is still probably the most popular one. So you can just launch that. So I'm going to launch that from command line. It's exactly the same thing. Okay. It's going to open a session in your browser. Okay. And after that, we will have a Jupyter Notebook open, and you'll be running that basically on localhost. Okay. That means we're running Jupyter Notebooks locally, and it's running on port 8888. And then you can create a new notebook, or you can open any existing notebooks as well. We can run Jupyter Notebooks in the cloud on, for example, a server somewhere in the AWS cloud running on the EC2 instance. When are we going to do that? Right now, we're just doing everything locally. But if you have a Jupyter Notebook you would like to share with your team, you might want to consider running that in the cloud. Right? So we are sharing a server with your team using Jupyter Lab. That's one reason why you want to do that. Or sometimes, if you don't have enough computing power on your local computer and you would like to train some large models, manipulate larger data set, you might need a more powerful server. Then I think the IP address here will change. It will change to an actual server IP address. Okay, so that's Jupyter Notebook, and that does require you to go to Anaconda, download, install, and then open Jupyter Notebook. So for today's session, I would recommend us just use Colab. Okay. This is kind of similar to Jupyter Notebook, and the good thing is that it's free and it doesn't consume much of your computing power locally, and it automatically save your notebook, and also it supports you have free access to GPU as well, so you can click on runtime and then change the runtime type, and you can choose a hardware accelerator, and you can change that to GPU and TPU. Google gives us, a standard GPU class for free, and it's automatically going to terminate that after your computer or this notebook become idle for over some time. And it's a great way to get started. So a lot of people, when they learn deep learning and they need a GPU, and Colab is a great way to get started. Okay. All right. I'm just going to open maybe I'll use, now that I have that, yeah, I'll just use, Colab, it doesn't matter. And what I'm going to do is I'm going to go to File and then click to open a new notebook. Okay. And in my local environment, I have Jupyter Notebook open as well. So I can just click on New and open a new Python session as well. Okay. And very similar. All right, let's get started. Let me make this a little bit bigger. Okay. We're on the basic syntax. On the left-hand side of this slide, you see Java programming, right? And you have to write, a class, and then you print something out. So Java is more verbose. If you want to print, a string, and on the right-hand side, you'll see that it's way easier in Python, right? It's interpreted language, so you can just hit print, and you see the color is green, it basically means that it's a built-in function. So you don't have to import any library. As long as you have Python installed, you can just run this right away, right? And if you like to print, let's say Python rocks as a string, and it's going to print out this string, okay? Inside this double quote, it is the string, and it's something that we would like to print. We can print a string, but we can also print a variable as well. We'll discuss that later. One of the good reasons to use Python Notebook is because it's very interactive, right? It's very easy to use. You just open, a new cell, and then you type in some command, and it will just, run the command, and it will show you the output. Okay. If you run that the second time, you see this number here in the bracket is actually increasing. So that means it keeps track of the state or the history, right? So this is the 5th time I'm running this cell. And, but of course, I'm getting exactly the same output. By the way, if this is the first time you're using Jupyter Notebook, you don't type everything in one cell, okay? This is called one cell, right? So you can go to cell, and you can run the cell, but you can also clear, right? Go to all output, and you can clear the output as well, okay? You can delete the cell. What if we would like to insert a new cell before this one on top? So what I'm going to do is basically just go to insert and select insert cell above. But I typically use a shortcut. You just need to highlight the cell that you would like to work with, and then just hit A. That means above, insert above. If you would like to insert below, then just hit B. Okay, so there's some shortcut you need to memorize, but once you start to work with, it's very easy to do that. What about deleting a cell? Right, of course you can go to cell and delete, but you can hit the key D twice. Okay, and you have to hit that quickly, and then it will delete all the cells. So that's insert and delete, and I think we're all set. We can start to do Python programming. Okay. All right. Oh, I think I forgot to mention something that's really important. How do we execute the code in a cell? Well, basically that means we need to run this cell, right? So we can either hit the run button in Jupyter Notebook here, okay, or you can use the shortcut, which is typically shift return. Okay, so you hit shift return, that runs the cell. Okay, in Google Colab, the shortcut will be slightly different, but if you would like to, let's say, run print hello, okay, and I will just open the kernel. So first of all, because this is running in the cloud, okay, we do need to run one cell or start the kernel, something called a kernel behind the notebook. And then after you run the kernel, it will tell you that, this is how much RAM we're getting. System RAM 12 gig. So if you find your computer slow, maybe you just leverage Colab to do most of the assignment or whatever, Python, running Python programs and doing data analysis. Okay, it's just like a personal laptop. Okay, let's move on. Okay, I'll skip some of these details. Okay. All right. Python runs code in the block style, which means the block of code defines the function to calculate most frequent value of an array in this case. So this is actually a Python function that we see, and Python used 4 spaces, okay, to separate different lines. So this is something called indentation. We use 4 spaces. So if we define this block of code, right, which is defining a function, and inside the code, if we run any programs, okay, we're going to do the indentation here. And if we have an if-else statement, and then inside this if block, we need to use indentation as well. And we can't really, see those, empty, spaces, but Python will detect that automatically. So sometimes if you only have 3 spaces, it will give you the warning. Okay. And identifier. What is an identifier? It's basically a variable name. But the variable here in Python, the official name is, an object, right? So everything in Python is an object. We'll discuss more about object in the next session when we introduce object-oriented programmings and functions and the modules, okay? But imagine that's just a variable, right? That has some value assigned to it. This is called an identifier. But it could be, a class. It could be a function. It could be variable itself as well. And usually to do assignment, we just use the equal operator. So in this case, it means the address underscore work, that is the identifier, right? But in this case, it's just a variable, and we can use equal, and then you can have a string, and that string is basically the address. So you can have the work address, you can have the home address, okay? So that's the identifier. Python has a list of keywords, and these set of keywords are reserved keywords. So in this case, for example, if we import keywords, it will show you basically a list of all the keywords, such as, for example, keywords, and then we can print keyword list that prints out a list of keywords in Python. Okay, so keywords in Python is typically bolded. You see import. Okay, that means it's a keyword. Okay, it cannot be used as a variable name. So for example, if we would like to do some sort of assignment, right, and you will say false equal value 1, okay, and it's going to give you an error, syntax error. It says cannot assign to false, and that's mainly because it's a keyword. So these are like reserved keywords, and usually when you get this kind of syntax error, then you know that it's reserved keyword. You're not going to use this as a variable name, okay? The good thing about Python is that if you try something, it didn't work out, then it'll read the error message, and then you know what's going on. So you don't really have to memorize all of these. Once you start to get more familiar with Python, most of the time you will avoid these, but sometimes, you just, use, for example, global as a variable name. You didn't realize that. And as long as you know how to read error message and how to Google, how to Stack Overflow, you'll fix problems quickly. And then you'll get more experienced over time, okay? When we write Python code, it's very important to, write comments, right? We can use the pound sign to write the comment. So in the Jupyter Notebook, for example, this is a comment, okay? And let's say print hello, okay? As you can see, it has different color, okay? The color in this case, it's green, okay? So this means that it is comment, okay? Second comment. When Python runs this cell, it basically skips the comment. And the comment is used basically for people who are reading your code. And sometimes, it's 3 months later when you come back to whatever program you've written in the past, you basically forget about what you did. And reading these comments will definitely help you, right? And when you work on bigger projects, it's usually some sort of collaboration, or you have team member who's going to do code review, right? So having well commented, code is always recommended. Okay, it makes other people's life so much easier. Okay, docstring. So docstring is another way to do comment. And typically we use the 3 quotes, okay? And so you can have multiple lines, and everything in the docstring are basically, some sort of descriptions, okay? And if you read some of the Python project code, you'll find that people use a lot of docstring. And in the Python function definition, it's also recommended to use docstring. It's always making your code more readable, so it's highly recommended. Okay. Okay, in Python, the end of line is usually, marked by the end of line, basically. And if you switch line, that's the end of the line, and it's going to just run the code line by line. Okay. And but if you have a docstring, then Python will note that it's going to span multiple rows until it sees the 3 double quotes. Okay. So these are end of the. So it could be end of a comment, right, or end of a statement, and Python will automatically detect that. Line continuation. So there are different ways to do line continuation. For example, in this case, let's say I would like to run some math operator. Let's say a equal 1 plus 2, right? So this is basically assignment, right? The equal operator here, and then we know 1 plus 2 is 3, so we can run this cell, okay? And so now this actually object A has been created. And where does it live? It lives in the memory. Okay, so we can actually reference and just print this, variable. In Jupyter Notebooks, you can just run this, variable name directly, and it'll give you the output 3. But you can use print as well. Okay. So we get 3, right? So we have an object A in Python memory, and it points to the value 3. Okay. But sometimes if but we're talking about line continuation, right? So you want to do 1 plus 2 plus 3 plus 4, okay? And if we do it, let's say this way, okay, then you're going to run into some, error message. It says, your syntax is incorrect because it's expecting something like after the plus sign, plus operator. Okay, so how do we do that? If the line is pretty long and you would like to do some sort of continuation, continue to the next line, right? So one way to do this is to use, the backslash, okay? And Python treats the backslash as the line continuation. So now if we print A, it's not going to be 3, it's going to be 10. So it basically does 1 plus 2 plus, and then line continuation, and plus 3 plus 4. Okay, so this is one way to do line continuation. Another way to do that is just use the parenthesis. Okay, if you put the parenthesis around, then Python will recognize that, if it goes to a plus operator and it's expecting a number after that, but because of the parenthesis, Python is actually going to continue to the next line. So if we run this, it's still going to give the correct results. Okay, so that's line continuation. We talked about indentation in Python. It's basically 4 white space that does the indentation. Okay, variables and assignment. We sort of talked about this already, right? A variable in Python is just a name given to identify an object. Okay, so basically everything in Python is an object. We'll talk about that later in the next session. Okay, it's used to identify data types, data structures, and other objects. We use the equal operator to do the assignment. And one recommendation is, for example, X, right? So equal. So we actually would like to basically create an assignment for an address, right? So X is probably not the best variable name to choose, right? If you're doing a demo, it's fine. But when other people are actually reading your code, you probably want them to know that this variable X is actually the address. So it's better to write longer variable names that's easy to read. That's actually recommended in Python. So sometimes when you see some like long variable names, it's actually not a bad practice. Okay. So in this case, you can write CN tower address, right? With you can separate different words by underscore. It's accepted in Python. Okay. And ideally all lowercase for variable names. When are we going to use our uppercase? It's usually used for constants, like variables that you think the value will not be changing. Okay, so the value of pi, and it can use the uppercase, all uppercase, to indicate that this is a constant value, or the speed of light doesn't really change. Okay. Some naming convention. So if you would like to, let's say, assign let's say Tesla. Tesla is the value of the object, and you would like to assign that to a variable name. You can use my car, 3 underscore model, but these are not suggested. So in Python, typically people follow something called PEP8. That is the style guide. So there's a set of rules that people commonly follow to write Python programs. So they follow PEP8. You never have to memorize this. The more programming you do, I think the more familiar you will get, with PEP8. But whenever you would like to sort of to check the style, you can always just Google Python PEP8, and there's like one really long page you can go through. Okay, just some examples here. Naming convention. Try to use all lowercase, right? And if you have actually multiple words like my car or Tesla model 3, you can actually use underscore to separate them. So these are suggested in PEP8, and people usually just follow that. And if you come from other programming, language background, they actually follow a slightly different, naming convention. Okay. All right, so this is a just very quick introduction to some of the syntax. Now I would like to move on to, there's some additional resources here you can check out, but you'll find all the slides on our WeCloudOpen Learning portal. Okay, now let's move on to data type. Just give me 1 second. All right, let's start from the beginning. Okay. Python has some built-in data types, and sometimes they're called data structures as well. Okay. But the data type I'm talking about here are things like string, numeric value, right? And later on, we'll talk about, the built-in data type or data structures such as, list, set, dictionary as well, if we have time. Okay. The most basic data types in Python are things like integer, floating point numbers, string, and Boolean. And we can use the operators that are associated with these data types, such as arithmetic operator, Boolean operator, comparison operator, and some of the basic string methods. Okay. And we can switch back and forth between different data types, and that is called type casting. Okay. For example, we can convert an integer into string, or convert string back to integer. Okay. So we can do type casting. The 4 basic data types: integer, right? These are whole numbers without decimal. And if you have decimal, basically they are floating point values. Okay. Boolean are basically either true or false, right? And then strings are basically a sequence of characters. I think these should be pretty straightforward, and we'll just do some coding here. Okay. Integer. Here on the left-hand side, I have some example, right? If we're looking at a company's, balance sheet, and there's some really large revenue numbers. And in this case, I think it's, let's say in 2015, Apple, whatever gross profit is $93,000 626, but that the unit is million. So that's 93,000 million. Okay. So that's why we don't need, in this, that's why we don't need the floating point. We don't need the decimal, right? So this is an integer, right? So let's say profit equal 9366. Okay. How do we tell it's actually an integer? We can use type, or you can just directly do type profit. Profit here is a Python variable, but it's also an object. We can always use, you see the color is green, type, right? It's a built-in function. So you don't have to import this, right? It's available in any Python prompt to get the type or the data type of an object. And here the output is int. So that means it's integer. Okay. If I change this to 0.5, now this becomes a floating point. And if you type profit, now it becomes float. Okay. But of course I can put a quote around it. So it becomes a string. STR is short for string. Okay. So I think these are pretty straightforward. So I'll skip some of these. And with these built-in data types, we can, for example, integers and floating point, we can apply arithmetic operations on it. Right? So you can do the division, right? We can calculate remainders. And I think we just tried, the summation as well. So I'll skip some of these simple examples. Okay, and you can watch the official recording later when you have more time. Now, string is something that's more interesting because in Python, string by default it's also kind of like a list. Okay, so I have some interesting example later. But let's say Marvel tweets equal Captain America. I'm not going to type all of them, but now I just created an assignment, right? So this object called Marvel tweets, okay, if print that, oh, sorry. Okay, let's print that out. So here's the string, right? A string as an object, it also has a bunch of attributes, right? So we can calculate, for example, the length of the string. So that tells you that we have actually 19, okay, letters. And string can be used, for example, there are methods that are associated with string, okay? So let's say we want to check if America is in this Marvel tweets string, okay? And it returns a Boolean. It says true, which means this Python object, which is a string type, it contains this substring America. Okay, so we'll cover some of these, built-in methods later. Okay, string can interestingly be concatenated as well. So here, let's say we have first name, Kanye, and then we have last name equal West, right? We can actually just use the plus operator, last name, and we get, or we can also add, let's say, an empty string in between. Right, so we can concatenate multiple strings. And that's because strings also work like a list, but we'll introduce Python list and we'll come back to this, okay? String can be sliced, which means that if we would like to, let's say, so that means we can do substring as well, okay? Let's say we have first name, winner is Kanye, but let's say, what if we want the first three letters, right? We can actually just do 3. Here, we're not using the parentheses. We're actually using the square bracket. Okay, so it kind of worked like a list, so it's basically saying that I'm going to do some slicing. The colon here means from 0 to 3. Okay, Python has something called index, and it's zero index based. So it basically means that, well, we're going to start from position, start from position 0, okay? And then this is 1, 2, so let's say 2, 1, 0, and 3. So 0:3 means that we're going to start from 0, go all the way to index 3, but not including 3. Okay, so that returns 0, 1, and 2. So it's doing some sort of substring, okay, similar to substring in SQL. And then we will get the first 3 letters. So that's slicing, which works very similar to Python list, okay? String has some method as well, right? For example, if we would like to convert a string to all lowercase, then we can do first name dot lower, okay? And you can run that, and that converts the uppercase K to lowercase k. But of course, that means you can convert everything to uppercase as well, okay? Okay, how do we know what kind of methods are available for any given object, right? So in Jupyter Notebook, what we can do is typically when we run a method, we're going to use the dot notation here, right? So that means, okay, for this object, I would like to call a method. A method does something. You know, it can convert the string to lowercase, it can convert that to uppercase. If you're not sure what methods are available or associated with this object, then you can just use dot. And in Jupyter Notebook, you can just hit the tab key. Just hit tab. Then it gives you the hint. So these are the list of objects that are available for this string data type. Okay, so that means we can do encode, we can do count, right? We can do ends with, and learning Python is just a matter of going through some of these, but definitely you don't have to go through each one of these methods. It's usually like when you need it, you're going to read the documentation, or you're just going to search or Google. And for example, let's say, let's try to find an example. Let's say lowercase, right? Or we would like to replace some substring with some other values. You can use dot replace, right? You can use split. So there are a bunch of methods that's available, and you can just read the documentation. Okay, that's probably one of the better ways of learning Python. If you start from the documentation, it's going to take you forever. Usually when you come across some sort of exercises, or there's a problem you're trying to solve, I usually begin with this and see, okay, so for this object, what are some of the available methods, and see, because the naming convention here is pretty intuitive, right? And is decimal, and basically check if it has decimal value, right? And you can do dot format, right? Or you can dot find, means to find something, right? And then you can read the documentation. That will help you save the amount of time you need to search for some solutions. And Google is also probably quicker. Okay. And at the very beginning of your journey, I think a lot of times the challenge is really just how do we Google about a problem? But I'm pretty sure you'll figure that out really quickly once you start to learn it. Okay. Some other popular methods, string methods, such as start with. So you can check if this Marvel tweet string starts with captain, right? And if it does start with captain, then it's going to return true, which is a Boolean, right? And of course, you can check if ends with something. You can do the replace, the split, okay? For example, let's say name equal Kanye West, and then we can do name dot split, okay? And it basically split the entire string by some sort of white space. and the output will be Kanye, comma, West. So that essentially split this string into two strings, and they're wrapped around in a square bracket. That's a Python list data type. Okay, this is one type of tokenization. When we do text analysis, we always need to do some sort of string splitting so that we can deal with the words and tokens instead of dealing with the entire string. But in natural language processing, there are other better ways to do the tokenization by using some sort of NLP libraries. Okay. And we can do join as well if we would like to. For example, let's say we have a list, right? So let's say dot join. Okay, so we have a Python list that has two strings. We would like to join these two strings. Okay, now it becomes Kanye pound West, or if you would like to change that to space, it's sort of the reverse of the split. Okay. All right. So that's a quick introduction to the basic, data types, and there's some operators such as Boolean, logical operator, or and. I'll skip some of these, and you can review them on your own. Okay. Now I'd like to move on to at least cover list today, and in the next session we can talk about maybe dictionary, and then we'll move on to Python functions and some other things like list comprehension. So I'll give you some examples of list. Okay. All right. What is a data structure? So now we're moving on to data structure. Some of the most commonly used data structures in Python include list, tuple, set, dictionary. Some people call that tuple. I never get it right, so I'll just call that tuple. Okay. What is a data structure? Data structure provides us with a method of storing a collection of related data. What does that mean? So it's like a container that allows you to store Python objects. Okay. Let's say in this case, we have a list of tasks. Okay. We have task A, task B, and task 3, right? Okay. So we have a list of tasks basically, right? So think of this as a list. Now, this container or this collection of data, right? Because the data in this case is just a task. Task A, task B, task C. They have some sort of properties. For example, the number of elements in this case, or the number of tasks, is 3. And that is actually a property, right? Just like when we calculate the length of a string, right? Let's say of some sort of string, okay? And then you want to get the very first element. And in this case, what is my first task? It's going to be task A. Okay, so that means you can use some sort of method, okay, to manipulate the data or to access the data. In this case, retrieve my first task, which is task A. But what if you want to do, okay, maybe I want to prioritize my task. I would like to do task C because it has higher priority, or I just want to reverse my task based on the urgency, not the priority. Okay, then we'll start from C, B, A. So that means you need to reverse this list. Okay, so that means we're calling a method to reverse the list, or maybe you want to delete a task. How do we delete that? Well, with this Python list object, we can run a method called remove. Okay, so a data structure, Python have different data structures built in, and a data structure is a container or a collection of data basically. And it has some sort of properties in this container, right? About this container, for example, the number of elements, right? It allows you to retrieve the first, the last elements, and you can reverse, change the orders. But what type of like methods that are available really depends on the type of the data structure we're working with. Okay, so we're going to talk about list, which is one of the most popular Python built-in data structure. It's basically just a collection of data or elements, right? On the very left-hand side, we need the name for a list, right? So that is, you can think of it as a variable, but in Python, we call that a list object. So in this case, let's say we would like to create a list that stores users' interest. So we call that user underscore interest, right? List is usually using the square brackets. Okay, so whenever Python sees a square bracket, it is a list. Okay, and inside the list, each element, right, is separated using comma. So it's comma separated. Okay, list is very flexible. So if you look at we'll discuss the attributes of a list. Okay, but let's talk about some of the real life examples, right? Let's say we would like to manipulate CSV file or a tabular data set in Python. So we can actually read this tabular data set. Let's say this is a table in CSV file, and we would like to read that into Python. It can read that in as a list of rows. Okay, so basically the way we can represent this in Python is we can use a list, which is a square bracket, right? And this square bracket holds a list of things, and each row, okay, is one element in that list. And the different rows are separated using comma. That's actually how we read, a Python, a CSV file into Python, and we can read that into a Python list, and then we can manipulate the data. But we're only talking about rows here. But if we would like to separate the data into columns, then each row can also be separated into comma separated lists as well. Now, when you look at this CSV file represented in Python list data structure, it's basically a list of list, right? So first of all, the outer list, the square bracket, separates the rows, and the inner brackets separate the columns, and they're all using commas to separate different elements. Okay, so that's one example. Some other examples. Let's say we're creating a shopping list, right? And there are a list of things we would like to buy. Okay, so how do we create a list? In Jupyter Notebook, we actually don't even need to do assignment. So we can just do, tuna. Right now we're manipulating strings, right? Macro, okay? And you can just run the cell. It's actually just going to print out the list, okay? But of course, step 2, we would like to assign that to a variable, okay? We call that oily fish. And I'm just going to copy this. On the right-hand side of this equal sign is the list. And then we basically assign this list as the value to this object, which is named oily fish. And then we can print that out. You can also use just print, okay? So that's how we create a list. Once we have a list, we will need to want to know, like, what are some of the characteristics of the list, right? What can we do with the list? So first of all, lists are ordered, right? So it has sequence, which means tuna comes in first, and it's always going to be the first. Okay, so lists are ordered, and the elements can be accessed by index. So Python is 0 index based. Let me see if I have a slide. Oh, I do have a slide for that. Why is it loading so slowly? Let's say we have a grocery list, right? Python is 0 index based, which means the first element has an index of 0. Okay, so if we would like to access tuna or the first element, we basically use position or index 0. Okay, so 0, 1, 2, 3, 4, 5. That means we have 6 elements. But reversely, it also works. Index -1 is basically the last element, -2, -3, and -6. So that's how indexing works in Python. Okay. So how do we access elements in a Python list, right? Let's say we would like to access the first element, then we have to use index 0, okay? Because we create the list using the square bracket, right? So when we actually access any elements in Python, we can use the square bracket as well, okay? So grocery list bracket 0 is going to return tuna, right? And 3 basically returns the 4th element, and in this case, it's going to be pasta. Okay, so that's how we access a value in the list, because the list is ordered, and that's why every time you provide an index, you're always going to be able to access the same element because it's ordered. Okay, and we can do slicing. Remember, we did that in Python string. String is a special case of a list. Okay, so that's why we can use the slicing to access elements. So if we do 0:2, that means we would like to access 0, 1, and not including 2. Okay, so it's the end position is actually exclusive. So in this case, 0 and 1, and it's going to return tuna and salmon. Okay, so that's how slicing works in lists. All right, and we can create a more complex list, and which is nested list. Okay, so here's one example. Now we create a list called condiments, and we have salt, pepper, but there's also another inner brackets here. Okay, because when you write a grocery list, right? This is the entire list, but you can have different categories and subcategories as well, right? And then you have bullets. This is how we can actually represent that in using a nested list structure. Okay, I'm not saying that this is the best way to represent it. We might as well use Python dictionary. We'll talk about dictionary in the next section, next session. Okay, but interestingly, that means the elements in a list, they can actually have different data types. And so far we've been dealing with strings, but the third element here is not a string. The data type is a list, right? So that means list is actually very flexible. It doesn't have to store elements that has exactly the same value. Okay, let's go back here. So some of the characteristics, lists are ordered. You can access elements by index. It can contain any arbitrary objects. This is why list is so great. Okay, it can be nested. And lists are also mutable, which means you can make changes. You can delete the elements. You can add new elements to a list. With some other Python data types, you cannot do that. It's mutable, okay, such as tuple. So we'll talk about that later. But let's try one example of a nested list. Let's say, maybe to save time, I'll call this. Okay, so we have variable called condiments. Okay, now it's a list of lists. Let me maximize this. Okay, if we would like to access the first element, we use index 0, condiments, right? And then we can access the first element, which is salt. Now let's try this one, because this one's a little bit more interesting. So To access that, it's going to be index. It's the third element, right? So it's going to be index 2. And let's try to get the data type of this third element. It should be a Python list. But if you try that on the first element or the second element, it is actually string. Okay, this basically proves that Python can hold any kind of arbitrary data types. Okay, so that's nested list. And how about mutability? So list is mutable, which means we can make changes. Right? So this is a grocery list. So maybe I changed my mind as I said, okay, instead of what's the first element? Salt. I would like to change it to something else, right? Let's change it to bass or, well, okay, tuna. Let's change tuna to bass, right? So probably to, let's say, grocery list equal, maybe I have it. No, I don't. Let's say tuna, salmon. Okay, I'll just have 3 of them. And this will be my grocery list. And let's say we would like to switch the first element with some other value. First of all, we need to access that element, which means we need to provide index. Let's say I would like to change salmon to something else. Well, we can access that element. It gives us salmon, right? What about we want to make some changes? We'd like to change that to, so in this case, we can do an assignment. Let's say we're going to access the second element in this list, which is salmon, and we would like to redo the assignment. Change that to bass. Okay. Now let's take a look at this list. It becomes tuna, bass. You see the salmon has been changed to bass. So this proves that list is mutable. You can make change. You can change the element value, right? But you can even remove elements, right? Let's take a look at some of the list method, okay? But there are some operators we can do. For example, we can run the length function of a list. Let's say grocery list. That returns an attribute, which is 3, right? That's the length of the list, okay? And we can run some sort of list methods, such as append, clear. We can create a copy of a list. We can extend a list. Pop means remove at certain position. We can remove certain value from a list. We can reverse the list. We can also sort the list. Okay, so these are the built-in methods. Let's try some of these. Let's say we have the grocery list. Okay, and we have 3 values, right? We would like to append salmon. Let's say grocery list. So that's the object, which is a list, dot, hit tab. That tells us like what kind of methods that are supported. And now we have append. Let's say I would like to append some new value, right? And if you're not sure how to use append, what kind of parameter it accepts, right? In Jupyter Notebook, you can run the shortcut Shift Tab. It basically prints the documentation, okay? And then we can click on the plus and it expands on it. In this case, it's pretty simple, so it doesn't have a lot of details, but we can also get help by just typing the help on any object in Python, and it gives you the documentation, okay? So we can either run help or we can do dot, and then you find a method, and then you can hit Shift Tab to get more details about this method, okay? So in this case, it's a grocery list, it's a list, right? So it tells you that, well, this is a class, Python class list, and it contains an iterable, and it has built-in mutable sequence, and these are some of the methods defined for this list class. We'll talk about class later, okay? All right, so, and then the ones that are in the slides, you can see them here as well, right? Copy, count, extend. So let's try some of these, okay? So I would like to append salmon, okay? So you'll notice that after we run .append, it actually doesn't print anything out, right? But behind the scene, salmon as a new element value has been appended to this list. So we just need to print out grocery list, and now we see that salmon has been appended to the end. Okay, we can do something like grocery list dot extend. Okay, append allows us to append a string or any kind of object. Okay, but if we do extend, it by default accepts a list. So it's basically adding or extend a list by adding another list of value, right? Because if we just want to append one value, we can use append. But what if we would like to, add a list of values? I'm just going to copy this here and say, okay, we would like to expand this grocery list, and I'm going to extend that with a list of values. Okay, let's try that. And let's take a look at grocery list again. Now it gets extended. It looks weird, I know, but sometimes it forgets that it actually has created list for Bass, and then you just write that down again, which essentially means that the list can accept duplicate value as well. Okay, so that's one of the attributes of list. So yeah, so that's extend. And but what if we forget this bracket? Let's say I'm going to extend that again with Bass. Guess what's going to happen? Find that out. Interestingly, we got BASS appended as separate strings. And that's mainly because, extend accepts an iterable. So it treats the string as a list as well, basically. So it's actually going to split this string into a list of like letters, okay? And then extends that as a list to the grocery list, which doesn't make sense in this case, okay? So you better use like append in this case. Okay. Yeah, so we introduced some of the list methods, and we can do remove and pop as well. Let's say, let's take a look at, now the good thing about Jupyter Notebook is that you can always just print out the object, right, and see, okay, this is what we have in this container or in this list right now. And let's try to remove something. We're going to call .remove, right? If you're unsure how to use it, you can always just use the Shift tab, right? It's going to give you some hint, and it says, okay, .remove, provide a value, right? Remove the first occurrence of the value. So let's say .remove Bass. Okay. And it actually removes the first occurrence of the bass, which is the one, the second word, right? Tuna, bass, and then it occurs, and then it gets removed. And after you print that out, the second bass is still there after salmon, right? Okay. And now if we would like to remove the second bass, which is now position 4, so the index should be 3, let's remove that, right? So I'm going to run pop. If you know the exact position, let's say pop 3, which is the 4th element, and let's run that again, and it tells you that it removes the bass, right? So now there's no bass in my list, okay? So that's the remove and pop, and we can do reverse, we can do sort. Yeah, and that's that's pretty much it. That's all I want to cover today, which is a quick introduction to Python. We talked about the basic syntax, and then we introduced the first data structure, which is Python list. And I don't think we introduced a lot of real life examples today, but if you do want to find some interesting exercises, I recommend you go to WeCloudOpen, and you should be able to find exercises and also the solution of those exercises. Okay. I hope you find this session useful, and I hope to see you guys again next Friday. Next Friday, we'll be introducing if else, some of the conditionals, and we'll finish the data types. So we'll focus on dictionary, which is very interesting data structure. And then we'll move on to functions. Hopefully we can cover up till function next week. And then the last session, we can introduce modules as well as object-oriented programming. But these are short sessions, so it's not enough time for us to finish everything. But I recommend you just go through the course yourself to get familiar with Python. Okay. All right. Well, thanks everyone. The recording will be uploaded to the learning portal. So I think I need to find a place to upload the recording. It's most likely going to be in webinar and events, and then you can filter on workshop, and then you should be able to find that. And then, yeah, I think the recording will be available on YouTube as well. So let me share a list of resources with you. If you would like to join our Discord channel, here's the link to our Discord channel, WeCloudOpen, YouTube, and if you would like to read the career guide of data scientist, I have the links for you guys. Okay. Thanks, everyone. I hope you have a great weekend. I'll see you guys next week.